Welcome, this is FlowSim, simulating Iperf under Mininet. My name is Sergio and I'm a student of Graduate Program in the School of Electrical and Computer Engineering in Unicamp. This course is Advanced Computer Engineering Topics and the professor is Christian Steven Ruthenberg. The main subject of this course is SDN, Software Defined Network, and I'll provide you an overview of some technologies learned on this course. So let's move on. What is SDN? Software Defined Network is an emergency architecture that is dynamic, manageable, cost-effective, and adaptable, making it ideal for the high bandwidth, dynamic nature of today's applications. This architecture decouples the network control and forwarding functions, enabling the network control to become directly programmable and the underlying infrastructure to be abstracted for applications and network services. What is FlowSim? FlowSim is a tool that helps you to learn OpenFlow quickly. In a minute, a user can configure an OpenFlow switch and a single step a packet through the OpenFlow pipeline. At each stage in the simulation, internal data structures are visible, so a user can see exactly how the OpenFlow pipeline operates. What is OpenFlow? OpenFlow is an open standard that enables research to run experiment protocols in the campus networks we use every day. OpenFlow is added as a feature to commercial Ethernet switches, routers, and wireless access point, and provides standardized route to allow researchers to run experiments without requiring vendors to expose the internal workings of their network devices. OpenFlow is currently being implemented by major vendors with OpenFlow-enabled switches now commercially available. What is Mininet? Mininet is a network emulator which creates a network of virtual hosts, switches, controllers, and links. Mininet hosts run standard Linux network software, and its switches supports OpenFlow for high flexible custom routing and software-defined network. Mininet support research, development, learning, prototyping, testing, debugging, and any other task that could benefit from having a complete experimental network on a laptop or other PC. Why use Mininet? Mininet provides an easy way to get correct systems behavior and to experiment with topologies. What is Iperf? Iperf is a tool to measure maximum TCP bandwidth, allowing the tuning of various parameters and UDP characteristics. Iperf report bandwidth, delay, jitter, and datagram loss. Iperf was developed by NLANR DAST as a modern alternative for measuring TCP and UDP bandwidth performances. Next, some TCP and UDP characteristics can be measured by Iperf. This is the topology we're going to use on this experiment. We're going to have two hosts, one named H1 and another named H2, and one switch named S1. Here are the characteristics of each one. To simulate the environment, we're going to use Mininet, and I already put it to run and have some configurations to do, which I'm going to show you. So let's go to the simulation. So let's start the simulation. First, I'm going to use the Mininet. I already have a virtual machine running in Mininet in my lab, so I'm going to connect it using PuTTY. First of all, I need to start X1 server and then provide the login. Okay. Nice. First of all, I want to show the code I used to create the environment. Here it is. This is a Python code. It's very simple, very easy. Here are the main part of the creation of the environment. As you can see here, I'm creating the host number 1. Here I create the host number 2, and here the switch. On this two lines, I create the link between host number 1 and switch number 1. And here the host number 2 and switch number 2. Very easy, very simple. Let's do it. Let's check if everything is working. Okay. So let's start and use Iperf between the hosts. Here they are. Host number 1, host number 2. It's very important for the rest of the simulation and to use FlowSim to know some information. So here are the MAC address and the IP address for the host number 1, and here it is the MAC address and the IP address for the host number 2. Very simple, nothing difficult. So the MAC address of the switch I will show later. It will be necessary to run the simulation in the FlowSim. Let's start the run the Iperf. First of all, let's start host number 2 as a server in listen mode of Iperf command. -s, here it is. And now I'm going to request the packets from host number 1. -t. They're running. Here they are. As you can see, we have the same information on both sides. So I use a 3.37 gigabytes of information in a bandwidth of 2.89 gigabytes per second. Of course, Iperf can be configured and you can get many other information on it. So this is Iperf and a very basic information about bandwidth and gigabytes information between two hosts. But now let's see how the packets run from one server through the switch to another server and how it gets back. So how a packet goes from one server through the switch to another server. That's what FlowSim is going to show us. I already create two packets, one called Iperf request and another one Iperf receive, which have the same structure: Ethernet, IPv4 and UDP protocol. I already put the information here, the MAC address from the source and the MAC address to the destination, and I put the IP address from the source and IP address to the destination on this one, and have the same and did the same to the other one. Very easy, very simple. For the rest, I create a profile named Iperf profile. Only have 16 ports, I don't need more than that. And 3 tables. One which is the main table of the profile and the switch, the table for request and the table for the receive. I could do it with only 2 tables, but I prefer to show you the request and the receive table. The switch, it came with the same characteristics of the profile, have 16 ports and 3 tables, the main, request and receive. The main, I put the information from the ingress packets to the switch. This is which came from the port 1 for host 1. Here is the MAC address from the source, the host 1, and when it comes into the switch, I'm going to perform some changes, which is the MAC address from the switch, which goes to the destination, and the MAC address of the destination. What remembers me? Let's show you the MAC address from Mininet switch, which I have. Here is one, the Ethernet of the switch, Ethernet 1 from the switch 1, and this is the second one, the Ethernet 2 from the switch 1. Okay, I'm going to use the same information I have on the switch from Mininet and the information I got from host 1 and host 2. So here it is, and after the change I'm going to use the table 1, which is the request table. On this table I'm going to check if the MAC address is the correct one, and then I'm going to send it to the correct port. Okay, the received table have the same focus. See if it is from the source, and if yes, I'm going to send back to the port of the switch which host H1 is connected. Groups and meters are not used for now. It's something on the next feature. So let's see the simulation. I already create the skeleton of the simulation. I have Iperf request, which is a trace using packet Iperf request, which is on the switch Iperf switch, which I show you I already create. So let's see what's happened to the packet during this travel. It came through the switch, my packet Iperf request. I'm gonna see the content of it. Then I'm gonna extract the information from all the protocols. Okay, all here, my IP address from source, IP address from destination, the source, the MAC address from source and destination. Okay, then I'm going to pass through the tables, see which table I'm going to use. First the main one, the selection. Well, I'm going to use the priority one and use these instructions for this package, which are as you can see, I already changed the MAC address from the destination, from the source, sorry, from the source to the MAC address from source of the switch, and apply it. Now I'm going to go to the other table. I get back to the choice. I select the table 1 as I put there. Let's see if selection matched to my choice. Is this one? So I'm going to apply the destination and output of port 10, and the packets go out from the switch. Very simple, very easy. Like I said before, this is a tool that helps researchers and some professionals and some students to learn more about FlowSim. Well, like I show you, I just send the request. What happens to the receive? Almost the same thing. Let's see. I receive into the switch the Iperf received package. I'm gonna read and extract all the information from the protocols. I'm gonna perform the choice. Table 1, the main table. What I'm gonna do, use this trace, execute. Like you can see here, I changed, the MAC address from the source from the MAC address to the MAC address of the switch. Apply. Nice. I'm gonna check the other table. As you can see now, is the table from receive. Selection, execution, then apply, and it goes through the port 1 and go out from the switch. And that's all, folks. I hope you enjoyed this video. As I wish to demonstrate, I show you how Iperf works. I show you about Mininet. We talk about SDN, Software Defined Network, and another stuff that I learned on this course. I want to thank Christian Steven Rothenberg and Unicamp for giving me this chance. Here is my email if you want to contact me and talk about a software defined network and instructor and technology. I'm open to. Feel free to do that. Thank you and hope to see you in the next video. Bye.